tonight we're going to continue with our geometry lessons for quadrilaterals. So you should take out your note packet and turn to the page on quadrilaterals. Meet the quadrilateral family. So we're going to go through each of the quadrilaterals and we're going to talk about different properties that they have. The first category is basic quadrilaterals, and a quadrilateral is a polygon with exactly 4 sides. So you should write that in the top of blank there, and it just has no distinctive features. So it can be any quadrilateral. It has any 4 sides. Now I kind of look at this diagram and I look kind of to the left there's one arrow and to the right there's another arrow. And to the left we have our trapezoids. I call those the West Coast quadrilaterals because they're kind of, you know, a little bit more liberal, kind of free birds of the California kind of out there people. Okay? So, or polygons I should say. So a trapezoid is a quadrilateral with only one. Only one. Very important. Only one. Oops, I didn't mean to check that out. I want to change that to a highlighter. All right. Anyway, only one set of parallel sides. All right. An isosceles trapezoid then is a very special trapezoid in which the base angles are congruent and the legs are congruent. So you should write that below the trapezoid. So you have little arrows going. And the base angles will be congruent and the legs would be congruent. This kind of goes like this on your picture. There's an arrow. All right. Now we're going to come over to the East Coast quadrilaterals. They're the conservatives. They're a little more on the conventional side. And the first one there is the parallelogram. So you're going to write parallelogram and then you're going to put these properties down. It has 2 sets of parallel sides. It has 2 sets of congruent sides, and they are the opposite sides. So this side is parallel and congruent to the one below it. The left and right are congruent and parallel. Opposite angles are congruent, and consecutive angles are supplementary. Well, if you think about this as being parallel lines, remember, if I'm looking at this here, and I have, these are just basically transversals on the other side. Okay, let me just straighten this guy out a little bit. Then these have to be supplementary because they are same side interior angles of parallel lines. Okay, and then that has to be supplementary with this since those are parallel, and then that would have to be supplementary with this. So that's how we get opposite angles congruent and consecutive angles supplementary. The rectangle has all of these properties, everything up here, and it also has 4 right angles, and the diagonals, a diagonal is this, sorry Miss Rectangle, Rita Rectangle, I'm drawing across her face, but the diagonals are congruent, okay? Then we move on to a rhombus. They're kind of like brother and sister. Okay, rhombuses and rectangles. And these are children of the parallelogram. So a rhombus has, again, all of those properties of the parallelogram plus 4 congruent sides. So all of these sides are congruent. Okay, also these are supplementary. These are congruent because it's a parallelogram, etc. Okay? And a square is everything, okay? A square has the properties of the parallelogram and the rectangle and the rhombus. I have it all. Yeehaw. Okay, so that's a square. So you should pretty much have the whole chart filled in except for that last little box down here, okay? The sum of all the angles of a quadrilateral. Now many of you know this. If you don't know it, it's 360. But one challenge I have for you, I want you to think tonight about why. What makes the sum of the angles of a quadrilateral 360? So I want you, everybody, to come in with some type of explanation on why you think that's so. I do also want to talk, this isn't in your notes, but I want to look at a different isosceles figure. We've talked about isosceles triangles. Well, this is an isosceles trapezoid, okay? Now remember, the base angles of an isosceles trapezoid are congruent, so that's going to be 75 degrees. We also know these lines are parallel. I'm going to put these little arrow things. That's a symbol for parallel. So what do we know about this angle here? We know something about it. This angle has to be 105 degrees. Now, if you thought about that, bravo for you. If you didn't, think about why that's so. I have parallel lines here, right? Cut by a transversal. That's a bad parallel line, but I'm drawing with a mouse, so you get the idea. So those interior, same side angles have to be supplementary. I'm going to delete that because it's just so embarrassing. Okay, so then I would also know that's the same over here. So you should be able to fill in all these angles, okay, in a diagram like this. This is 100, so this base angle down here would have to be 80. And I know base angles are congruent, so that's 80. And these are supplementary, so that's 100. So you should be able to figure out all those angles. All right. We can look at this picture for a quick minute, and I could have you guys fill this out. Okay, so look at it and just kind of use scratch paper and figure it out. You could pause here, okay, and try and figure out those three questions. All right, so here, paused, you figured it out, right? You did it on your own, right? Okay, this would have to be 100 degrees. Why? Because these lines are parallel, it's a trapezoid, and they have the same side interior are supplementary. I know that my base angles are congruent, so this is 80. And I also know these are also base angles. The ones at the top are also considered base angles because I could have this trapezoid tipped upside down. Okay, this is a rhombus. So these sides are parallel, which means these angles are supplementary, which means that has to be 60. And then this opposite angle would also be 60. And this one would be 120. I add all these up. Okay, and the third angle, I would subtract it from 360. This angle would be the sum of all three of these subtracted from 360, which I believe is 95. Terrific. Okay, so now I want you to do the back of that quadrilateral sheet to finish up. Who am I? And that will be your quadrilateral practice for now. I will see you guys in the morning. Have a great night.